Let's go on to question 6 on differentiation this time. Question 6 is the equation of a curve is given by y equals to x plus sine square x for x more than or equals to 0 and less than or equals to pi radians. So take note that this question is in the form of radian, okay? So you need to change your calculator from degree to radian. This is something very important because if you fail to do so in exam and the question is in radians, yet you are doing it in degrees, you can lose a lot of marks. So please take note of this over here. Okay, so you just have to take note of whether the question is asking in terms of radians or degrees. Okay, so the question asks us to write down the expression for dy dx. So we're just going to differentiate y. So dy dx is actually equals to 1 plus 2 sine x cosine x, right? And this is equals to 1 plus sine 2x. This is because 2 sine x cosine x is actually equals to sine 2x. Okay, so that's for part I. Now, let's move on to part II. The question asks us to find the stationary point of the curve. Now, as you all have learned, in order to find the stationary point, right, so we have to actually equate dy dx to 0 so that we can solve for the x coordinates of the stationary point, right? Because at the stationary point, the gradient is 0. That's why if we equate dy dx equals to 0 over here, solving it will give us the x coordinates of the stationary point. So here dy dx is actually 1 plus sine 2x. This is equals to 0. So let's bring the 1 over to the right hand side. This is equals to minus 1. Okay, so you can see that the question says that they are looking for x between 0 and pi radians inclusive. So in that case, here is 2x, right? So then this means that if x is more than or equals to 0 and less than or equals to pi radians, equivalently 2x is more than or equals to 0 and less than or equals to 2 pi radians. So here I times 2, here I also times 2. Okay, so think about it this way. So sine of what angle is actually minus 1. So this means that 2x can be equals to 3 pi over 2 radians, which is equivalently 270 degrees, because we know that sine of 3 pi over 2 radians is actually equals to minus 1. And we also know that we can add 2 pi radians to the 3 pi over 2 radians. So sine of 2 pi plus 3 pi over 2 radians is also equals to minus 1. Okay, but this is rejected over here. That's because since we are looking for 2x more than or equals to 0 radian and less than or equals to 2 pi radians. So this is the only answer that we will be looking at. Okay, in that case, let's find the value of x. We divide the 2 over. So this is actually 3 pi over 4 radians. Okay, so we have the x coordinate of the stationary point now. In order to find the y coordinate of the stationary point, we need to substitute this value of x into the equation of the curve over here. So y is equals to 3 pi over 4 radian plus sine square 3 pi over 4 radians. Okay, now in this case, this value is actually equals to let's see, so this is actually equals to 3 pi over 4. Okay, let's see, so the sine of 3 pi over 4, okay, radians, and you square it, this value over here is actually equals to half. So we plus 1 over 2. So we have our x coordinate of the stationary point and our y coordinate of the stationary point. So which means we can conclude with the statement, therefore the stationary point is (3 pi over 4 and 3 pi over 4 plus 1 over 2. Okay, so this is the x coordinate and this is the y coordinate. Actually, we can combine these two fractions as 3 pi plus 2 over 4. Okay, that will be neater. Now let's move on to sorry. So let's move on to okay. So there's actually a part 3 to this question. Okay. So I'm just going to write down the part 3 of this question. The question asks us to determine the nature of the stationary point. Okay? Determine the nature of the stationary point. So there are two ways that you can go about doing this question whenever they tell you to determine the nature of the stationary point. The first way is to use the first derivative test. You check the gradient to the left of the x coordinate of the stationary point and to the right of the x coordinate of the stationary point. So that's the first derivative test. You check a little bit to the left of the stationary point and a little bit to the right of the stationary point. So this is a little bit longer, but this is the first derivative test. The second derivative test, you can actually use d square y dx square, and you can substitute the x coordinate of the stationary point into d square y dx square to check on the nature of the stationary point. So over here, I'm just going to say that if I were to do the second derivative test, so this will give me 2 cosine 2x, right? Now if you substitute the x coordinate of the stationary point over here, 3 pi over 4, in here, okay, you will realize that you get let's see, yeah, you get that d square y dx square is equals to 0 after substituting the x coordinate of the stationary point here. So it is inconclusive. So in that case, you would be required to do the first derivative test, right? A lot of students they prefer the second derivative test because they feel that it is straightforward. That is true only if when you find, it is true that the second derivative test is easy only when d square y dx square can be found easily. Okay, if you ever realize that when you do the second derivative test, meaning when you find d square y dx square and it is very difficult, now please don't do the second derivative test. Okay, just use the first derivative test. Okay, in this case over here is because the d square y dx square is very easy to obtain, but however it is inconclusive because after substituting the x coordinate of the stationary point into d square y dx square, you get the value as 0, so it is inconclusive. So you must go back to the first derivative test. So over here we're going to do the first derivative test. So we're going to draw a table. We have x and a dy dx. So we're going to look a little bit to the left of the x coordinate of the stationary point. We already has 3 pi over 4 minus, and then we have the x coordinate of the stationary point, 3 pi over 4, and then we're going to look a little bit to the right of the x coordinate of the stationary point, 3 pi over 4 plus. So after substituting this in, okay, you will realize that if you substitute this into dy dx, you get that the gradient is positive, and this is obviously 0, and you get that the gradient over here is also positive. So which means this is how it will look like. Okay, now this means that the stationary point is a point of inflection. So that concludes the question on question number 6.